What is acid deposition? There are two types of acid deposition, wet and dry deposition. Most of us by now would have heard of a type of wet deposition, acid rain. Other forms of wet deposition include snow, hail, and sleet. Dry deposition, on the other hand, is when acidic particles fall back to the Earth's surface. But how is acid deposition formed? It is formed when nitrogen oxides from combustion of engines, which makes nitrogen monoxide, and electrical storms, which cause oxidation of nitrogen monoxide to make nitrogen dioxide. They react with water vapor in the atmosphere to form nitric acid and nitrous acid. Likewise, sulfur oxides from volcanoes and combustion of fossil fuels with sulfur in it react in the atmosphere with water to form sulfurous acid and sulfuric acid. Although rain has a natural acidity of 5.65, the small pH change caused by the nitrogen oxides and sulfur oxides can have a massive impact on the environment. For example, buildings made of stone with calcium carbonate in it would become corroded over time as the sulfuric acid in the rain reacts with the calcium carbonate to make calcium sulfate, carbon dioxide, and water. As for lakes and rivers, when the pH decreases below pH 6, pH-sensitive organisms such as salmon, insects, and insect larvae and algae start to die. When the pH declines below pH 5, snails and microscopic organisms can't survive. A lake or a river with a pH of 4 is pretty much dead. When it comes to trees, aluminium ions leach into the soil water damages roots, so trees can't take up enough water and nutrients. Additionally, increased acidity in the soil causes vital nutrients to leach out, including calcium, potassium, and magnesium ions. A lack of magnesium ions would cause a decrease in the amounts of chlorophyll, so less photosynthesis would occur in plants. You can see symptoms of acid rain in a tree if you see stunted growth, a yellowing of the leaves, and also a thinning of the tree tops due to the loss of leaves. Acid deposition can also affect humans. Sulfur oxides and nitrogen oxides can irritate the mucous membranes when they are dissolved in water. This can increase the risk of respiratory lung diseases like asthma, bronchitis, and emphysema. When nitrogen and sulfur oxides react in the atmosphere with water vapor, the actual mechanism involves hydroxyl radicals, which are highly reactive molecules that consist of one oxygen and one hydrogen. You can see why the radical is so reactive. It has one unpaired electron. These hydroxyl radicals are formed in the atmosphere when water vapor reacts with ozone, like in the first equation. It can also be formed by one molecule of water reacting with one radical to make two hydroxyl radicals. So now you know how the nitrogen and sulfur oxides react in the atmosphere, and why it is so important to try and reduce the amount of sulfur and nitrogen oxides since hydroxyl radicals react so readily to them.